Hello, everyone, and welcome to today's webinar, Coding for Homeschoolers, a step-by-step guide for parents and educators. Please join me in welcoming today's host, David Dodge. David is the founder and CEO of CodaKid, a game designer, educator, columnist, and speaker. He's credited in the development of over 30 video game titles for Sega and Sony and blogs frequently on kids coding education. David has taught tens of thousands of children in over 80 countries how to code, so I am very excited that he is here to talk to us today. And with that, I will let you take it away, David.
All right, hello. So thanks for that nice introduction. We are going to do primarily just a video webinar today. I personally fall asleep during PowerPoint style webinars, so I figured I would try to make it exciting, and I'll maybe do some screen share as well to show you a few websites that I like and whatnot. But in any case, I want this to provide a lot of value for you, and most of you, I believe, are going to be interested in teaching computer programming to your homeschoolers. And it's a very hot topic in the homeschool communities, as we know. It's also something that that I hope I will help you understand better, and it's something that first, what I think we'll get into is a little bit of why I think that homeschool families are an ideal environment to teach computer programming, why computer programming is important, and then we'll get into some practical steps on how we can set up an effective homeschool curriculum for your family. So first of all, I learned how to code late in life, in my 20s, and it was something I had to learn for my job at the time. I had to work extremely hard to learn. Now here at CodaKid, I'm now watching 8, 9, and 10-year-olds that are becoming fully fledged software developers here at our academy. In addition to running our online courses all around the world, we have an actual physical academy, which is what you're seeing here. You might see Lucy, our Chief Love Officer, who is lying on the floor there. But in any case, we run live kids coding courses here, and have learned quite a bit. Coding or computer programming is, as most of you know, that coding is an expression. But why is it important, and why should we care? Why should we include this in our curriculum? First of all, you can obviously point to vocational benefits. Essentially, the average salary for computer programmers right now is $103,542 a year. We see a lot of students coming straight out of university with skills and are getting 6-figure salaries right out of school. That is obviously front and center for a lot of families. Even if you are not planning on, maybe your child isn't planning on becoming an engineer, wants to do other things, coding is, it's a tremendous discipline. I personally believe it should be part of every liberal arts curricula. The things that it basically does is it strengthens your math ability. It teaches problem solving. It teaches logic, procedural literacy. It can help your reading. It can help your concentration. It can, effectively, I believe as a creative, coding is very creative, especially as you get into its higher levels. And what other skill can you learn? What other skill is there in the world where you can actually build an application that within a matter of minutes can be instantly used by millions of people all over the globe? So it is a tremendous skill. We are seeing a lot of students, again, that feel like they're not good at math, that they're not good at science. They learn how to build a game or an app in coding. They see math and science literally come to life in front of them. It makes math and science interesting. And suddenly we're hearing from lots of our families that students have built confidence, and suddenly they're actually find that they're actually quite good at math. They just needed that, that to have their interest peaked. Coding as taught to students in college is very different than kids coding. Our academy teaches kids ages 6 and up how to code. My daughter is a 6-year-old, and so we've started at the very, very basic levels, and basically you can start actually as early as 5 with certain resources that we'll get into in a minute. As far as it goes, we'll with coding resources that young, we'll talk about this in a minute, but we strongly encourage you to use what is called visual block coding, which alleviates the need for typing and hunting and pecking on a keyboard, and allows you to actually move virtual blocks. I think of them as virtual Legos, where you can piece together functions and events and sounds and basically if-then statements and things like that. And even the kids at age 5 can follow along and learn how to do those things. Many of our families feel very uncomfortable at the thought of teaching students how to code because they don't have engineering backgrounds, and they find it all very intimidating. All I have to say is I completely understand. I also think that if you do it right, that you actually, almost anyone can oversee a homeschool tutoring, a homeschool coding environment. And there are just a few basic things you'll need to do. Like anything else, you'll have to just go for it, jump in. There are a lot of resources out there that can help you, and including, and we'll get into this in a minute, but there are a lot of providers out there that actually can provide you with virtual assistants through messaging and screen share if you got stuck and you just simply couldn't progress. So as far as it goes, the general homeschooling tips as far as how to put together an effective kids coding program, and this, maybe some of you might disagree with what I'm about to say, but I've taught a lot of kids how to code, and we've found that this is a best practice in our world. But number one rule in teaching kids coding is make it fun. If you make coding too academic, if you do projects that maybe are not very high interest for your student, what you'll find is they will stick with it for a short period of time, and then they will fall away, and potentially for forever. They'll lose interest and say, "Hey, I'm just not. This isn't my thing." With regards to that, many people always ask us here, because we do use projects here at CodaKid, like we teach using video games, and we program drones, and we program robots, and we make apps and websites. But video games are definitely a big core to what we do. And a lot of parents will ask, well, how is this practical? How is making a game really prepping my student in computer science? And the answer to that is that making games and apps actually use all of the same concepts that you would see building a Southwest Airlines ticketing app. For example, Boolean logic. If this condition is true, the computer will do this. That is the foundation of computer science. That is at the most basic level, the types of decision making that goes into both a Southwest Airlines ticketing app and a game. And then you also will see many of the same things in making games that you would building business apps, like, for example, loops, conditionals, variables, functions, switch statements, you name it. The difference is, if I try to force a new kid to learn how to build a Southwest Airlines ticketing app, they are going to go running out of the room. Whereas if I say, "Hey, do you like Minecraft? Oh, well, let's build a custom pickaxe that you're going to design, and then we're going to actually use Java code, and we're going to put it into the game." Their eyes will just light up, and they will put in the work. It is the ultimate carrot stick. They will work really, really hard, and they'll solve problems. They'll solve bugs. They'll be patient. They know that the payout is going to be this pickaxe in the game that they're really into. Look out! You're going to have a lot of very interested students. So another homeschool coding tip is, enroll in classes. If you have a very self-directed student, you could order some, maybe some books or, things like that. But this is the YouTube generation. Maybe you don't permit your children to watch YouTube, but I guarantee they'll like video delivery in general, especially if it's fun and humorous and light. But there are a lot of increasing number of kids coding online providers that use video to teach. And it's fun, it's self-paced, and again, there's a variety of different options for all interests, and an increasing number of them are actually providing support as well, which is great. If they get stuck and they're just like, I can't progress, you can get help and get back on track. Another option is for homeschool families you may have local academies in your area that are offering live classes. And we do that here in Scottsdale, Arizona. And we have a number of homeschool families that just love to bring their students here to the academy and to study with our engineers here. And it's generally a really a fun way to learn. You can look online and do some searches for kids coding classes or kids coding courses. Alternatively, you could look for a tutor. I always recommend, if you're going to do it independently, that you run a background check on anyone that you would work with. We like resources like IntelliCorp can run effective, very inexpensive national background checks. And in some states you'll have DPS fingerprint clearance cards and whatnot. Just obviously be careful. But it's a fun way to learn if you have those resources in your city or community. The other thing that's really fun is maybe you could find, join, or start a homeschool coding club. Those are popping up all over in the Phoenix Valley area, and that's a ton of fun because you can coordinate with other like-minded families, and you can share the costs of getting a teacher or maybe a local engineer that likes to volunteer. You can put together a group and maybe do it in a garage somewhere, or maybe do it at a local library. See where you could book a room in a community center and do something consistent. That would be really fun. That might be a fun way for you all to do that. Another thing, and this may sound surprising to many of you, but people in the tech community, a lot of them are really, really nice people, and they are really passionate about coding, and many of them view it as the great equalizer, that coding skills it doesn't matter where you're from, your background, your race, ethnicity, your language. If you can learn how to code, you basically have almost a guaranteed pathway to the middle class. And this is what a lot of developers are into. They love volunteering, and we are approached by full stack developers here at CodaKid all the time. We'll have them come in and help. They'll come and talk to our kids. They'll do webinars with them. But you can basically potentially find a mentor. Maybe it's someone you know. Maybe it's a friend's family. Maybe mom or dad is an engineer and wouldn't mind helping you out from time to time with your Scratch class or your CodaKid class, whatever that might be. But in any case, that's another thing that I think would be nice. So I'm trying to move very quickly because we have limited time, and I will be answering questions at the end. I'm noticing quite a few coming through on the chat, so thank you for those. So I want to get into a bit about languages and curriculum and how we as homeschoolers can kind of navigate that situation. First of all, I had mentioned earlier, that visual block coding is a great way to get started with coding. One resource that we really like, and I bet some of you have already used these, but these are some cards actually you can get. But this is Scratch Junior, and this is regular Scratch. MIT Media Labs, under the guidance of Mitch Resnick and his team of engineers, put together a free kids coding site, and I'll put in the chat in just a few minutes that URL, but if you Google Scratch MIT, you'll be taken to their website. And just a heads up, I mean, freshman year engineers at MIT take a mandatory Scratch class. Scratch can be used to make very basic games for 6- and 7-year-olds. It can also build full-scale, really complicated games that challenge even seasoned engineers. It's really fun. It's free, and a great. Thank you for putting that URL up. I appreciate that. That's a great website and one of our favorites. Let's see, another website that we think highly of. This one has a lot of free modules, but it's It's basically, think of it as a more curated, a more curated version of Scratch. Think of Scratch as kind of a sandbox. You can find lessons that will be excellent on Scratch. But Tinker, which we just put that URL up, again has some free resources. But they also, if you do their very inexpensive subscriptions, they will provide you with a number of very interesting, what we call closed platform kids coding courses. And why I particularly like them is that they have relationships with some very fun and interesting kid-friendly companies. My daughter takes the Tinker Barbie course, and that is really fun and very engaging for her. They also have a Minecraft relationship with Minecraft, so they have some Minecraft stuff. And in any case, it's an excellent site that we, again, think very highly of. Let's see. As far as robotics and whatnot, we're probably going to see a drone flying around in the background in a few minutes here. But we really do like our friends over at RoboLink. They are excellent. They have very fun kits that are reasonably priced, that have a ton of replay value. We actually did an online course for their drones, their CoDrone product in particular, and it uses Arduino, and it's very fun. A lot of kids really love robotics because it's very hands-on, and it involves making things. So you'll have some students that just really gravitate towards that. RoboLink also has a kit called Rocket, which is very cool, that allows kids to build custom robots from the ground up. So it's not just like, hey, put this screw here, put this chassis here. It actually allows you to get creative and make your own robot, which is really fun for kids. And then lastly, their third product just came out of Kickstarter, and it's called Zoomy. And we were the first camp in the world actually to run Zoomy camps. But Zoomy is a self-driving car robot, which is really neat. And never fear, it's not for street use. It is a small little car that runs, cruises around on your floor. But it uses Python, and it's really, really fun. As far as other resources that I think are excellent for kids coding, code.org is free and fun. This is, again, great they have stuff for ages 5 and up. Everything on it is free. They have been providing kids coding courses now to hundreds of millions of kids all around the world. As far as a fun, very well curated, closed platform site, highly recommend that you check it out and see if you can get your kid engaged on that site. It will be easy enough, and there are enough standard error messages if you run into a problem that chances of you even needing to step in and help your child are very slim. So that would be another site that I really do highly recommend. I will do a little push for our site and our, again, this webinar is not for me to sell our product. I really want you all to set up effective programs at home. But our site is quite good, and here is our link. The Homeschool Buyers Co-op has some of the best pricing that you'll find on our product. Actually, it has the lowest pricing for our monthly subscription that you'll find anywhere in the world. And what CodaKid specializes in is we curate Scratch courses. We teach with video tutorials. And our objective is to get kids to graduate from visual block coding into doing the real thing. And so we actually teach kids coding with professional tools and languages. We build very interesting projects, and our subscription site has 40 courses ranging from Minecraft modding with Java to Python game development to web development with HTML, CSS to Roblox game programming, which is very, very popular, and a variety of others, including JavaScript and Unity, which is a really interesting platform. Again, if as a homeschool family, if you need help with CodaKid, all you do is basically use a little red chat window at the bottom of your screen, and you'll basically be connected with our engineers, and all of our messages are CC'd to your email. And we'll even jump on with parental permission if you need us to do a screen share and see what's going on your screen. If you have a really bad bug that you can't solve, that's why we're here. So enough about CodaKid, but again, a very interesting resource, and we're very popular in the homeschool community. So let's see. Other things. A lot of families that are ready to jump into text-based coding ask this question all the time. And in the few minutes remaining, I'm going to just address this really quickly. But they always ask, what language should my child learn? And our approach here, again, maybe some people may disagree with this, but coding is challenging enough. It is demands concentration. It demands consistent focus and problem solving. It's fun. It's really, really fun. But it's also, let's face it, it can be rigorous. My advice to you regarding language is think first about what your child wants to do. Some children are really excited at the idea of learning how to build a website. And if that's the case, provided that you're ready to move on to text-based coding, I would say, invest in an HTML, CSS resource, whether that's something on Homeschool Buyers or you can find tutorials online, or if it's a CodaKid course, whatever that might be. Others are really into Minecraft, and even though Java isn't my favorite language to teach kids, students that are into Minecraft are going to be able to learn really important concepts and gain a lot of confidence, and I think catch fire in terms of really getting passionate about learning how to code if they can see some creations that they've made in the game that they love. Others are maybe just more sort of generalist. Maybe some are into 3D games. That's how I would direct you, is find out what your child is really passionate about, really interested in, and then head that way, whether it be robotics, 3D games, whatever it might be. Initially, I would say, rather than investing in a whole bunch of stuff, why not try some free resources, see if it's something that interests your child. Try code.org, try Scratch. You could there's some resources even on Khan Academy that would be fun that you could try for older students. But then once you've done that and they've displayed interest in it, then maybe, again, I highly recommend you go with the child's interests. Our two favorite languages for teaching kids coding, well, our top three. Number one is Scratch, just for getting those concepts across to students. Number two is Python. Python is very clean, very elegant scripting language. It's being used now. It's one of the fastest growing languages in the world. It is the language of data science. It's becoming the de facto language of artificial intelligence and machine learning. It's a fabulous language that also is very similar to written English. So it's a very great language for kids to learn. And CodaKid has Python courses that are very, very popular. And we will be launching a Python course on the Homeschool Buyers platform at some point later this fall that maybe you'll look out for as well. Another language that we love is JavaScript. JavaScript is the language of the web. What's really fun about it is you can build really fun games and apps that are browser-based and that you can play on almost any computer and tablet or whatever that might be. And that's a really fun language to learn. So now, as far as just one last thing, what computer do I need to invest in to teach an effective homeschool coding course? We get this question a lot. You can, again, if you're going to get into coding, a Chromebook is not going to get it done. You will need to invest in a Mac or PC. We love PCs around here, but a lot of developers strongly disagree and are maybe throwing food at the screen right now at my statement. But we use PCs here. We, again, you can buy refurbished grade A HP laptops on sites like Newegg for $250 that will have 8 to 12 gigs of RAM and a decent video card. It'll be something that you could use for years. Something we always point out to parents. Macs will get it done. They're great. You can't go wrong with a Mac. Most coding courses that use professional tools and languages will require PCs and Macs that are probably like 3 to 4 years old. If you've got an old PC or Mac that's been lying around in your closet for 12 years, it's probably not going to be great for a number of best-in-class coding resources that are out there. On the other hand, if you have a younger student and you're just getting started out and you want to use sites like code.org and Scratch, you can really use almost anything. You can use a Chromebook, you can use an older PC, basically anything that will access the internet. I mean, for the most part, if you can open up a web browser and get going. Most of them, some of them may have some tech specs. If it doesn't work for you, you'll need to maybe invest in something a little newer. But you can do Scratch on iPads, on tablets. You can do code.org on almost any device. So those are great ways to get started, and maybe you can figure out, how, if your student is displaying an interest and aptitude for this, and you would like to invest, again, go the Mac PC route, and you'll be fine. Considerations for, for Christian and other religious families. I know a lot of you out there that homeschool are concerned about that, and just did want to just say all of the resources that I've mentioned are very family friendly. And again, the resources that video games are. Maybe some of you will find some games out there that you'll be able to suss out the sites, but most of them are very, very tame and involve a character jumping over the lava onto a platform, things like that, challenges along those lines. So I'm going to I'm going to basically start looking here at some of the questions. So let's see, how many kids do you say should be in a class? Okay, got it. All right. So I'm going to open this up for questions now, and I'm seeing one from Nicole that's basically asking, how many students should be in a coding class? What's the max number of students? I'm taking the question is, what's the max number of students should be in a class, for it to be effective? So obviously, lower the student-teacher ratio, the better. But I do want to say that the most effective way to learn coding is not in a direct instruction environment. It is actually in what we call a blended learning environment, where students can progress at their own pace and get help when they need it. When we taught direct instruction here at our academy, we found that the entire class was going at the speed of the slowest student, and basically the faster kids were frustrated, the slower students felt frustrated. If a student had a bug, the teacher would go over to help that student with the bug, and basically the entire rest of the class had to basically wait. So coding is very different than teaching, say, history or philosophy or courses like that, in that it really, I strongly recommend having kids do self-paced learning. It is optimal for the homeschool environment, and it is optimal for teaching computer science. Let's see, will you have additional courses in Unreal Engine via Homeschool Co-op in the future? Yes, we will. So Unreal Engine is a very neat course. I do recommend, if you are a subscriber to CodaKid and you've done our Unreal Engine courses and you're done with them, I highly recommend that you try our latest Unity course. We teach you how to make a Mario Kart racing game from the ground up. And that's, again, an engine very similar to Unreal. And it also uses C# programming, which is a bit more advanced than Blueprint's Unreal. So it would be a really great resource for you, and I highly recommend that course.
David, how have you found teaching your own daughter to code is different from teaching other people's children?
So that's a really great question. I think that some students do not enjoy being taught by their parents, and some do not mind it whatsoever. Again, our daughter has done primarily, like in the very beginning, done more hands-on project-based coding through Tinker and robotics kits. And now she has moved on to more self-paced, so she feels more independent. But I would say the difference between teaching my own child versus teaching others is that I know my child obviously much better. I can tell when she's lost or confused very quickly, whereas sometimes students in classes are a little harder to read. I also know what her interests are. I know when she gets frustrated and needs a break. So yeah, I would say, if that's, I don't know if that's helpful, but that would be what my experience has been.
Oh, absolutely. And how young do you think kids should start being exposed to coding and in a very basic level?
Well, I think that the learning that takes place when learning, when doing, for example, I think I had mentioned Scratch Junior. This is designed for ages 5 and up. Again, really bright 4-year-olds will be able to do Scratch Junior as well. But kids put together what we call procedural literacy, understanding that because this happened, this will happen. Like kids go from being able to merely perceive the world to perceiving that there are connections between events. And I think coding can really help with that. So again, it's helped our daughter's reading, it's helped her math, it's helped her problem solving, her patience, her understanding of how to run. We do ours on a laptop, so she's gotten quite good with a mouse and with the keyboard. So there's just been a number of benefits, and she's doing very, very well right now.
That's so cool. And then, you know, when kids are starting to code, you're opening up this whole world of the internet to them. How do you recommend parents keep their children safe when all of this can suddenly be at their fingertips?
Yeah, that's a great question. Again, I look at having kids playing on the web, sort of like I view having your kids play in the front yard. You obviously want to be very, very careful and track what sites they're visiting. We recommend there are a number of really wonderful filters out there that you could invest in that could help you prevent your child from visiting sites that are inappropriate. That can help you as well. Some of the filters that are out there will even restrict the hours that they can use technology in the home. It's really nice if you have a larger family and you want to set up times for people where they can use things. For the most part, most of the resources that I'm giving you are what we call asynchronous resources that do not involve social at all. So code.org and Scratch, I guess you can share your projects to in Scratch you can share it to the community, but it's very protected. One platform that you have to be careful with is Roblox. We love Roblox. Roblox, when set up correctly, is one of the safest platforms in the world. And what you just need to do is that you set up your profile correctly. You can use a parent PIN to make sure that you can prevent your child from joining any social functions on the platform. But as far as a platform for game building and coding, it's fabulous, absolutely wonderful.
Awesome. So I'm going to bounce it back to some of our attendees. Megan was curious if you could list some basic specs for a refurbed laptop, such as RAM, memory, that sort of stuff.
Yeah, sure. So again, the more RAM, the better. I'd say minimum 4 gigs would be what I would shoot for now. As far as a processor on the PC side, I would say, if you can do an i5 or newer, that would be optimal. You could probably, an i3, if you could find a refurbed i3, that would be fine. Again, one thing, if you're going to be buying refurbed, is only buy grade A. Make sure that that you're not buying just some. If it doesn't say grade A on it, I wouldn't buy it. That's my personal view. Newegg will clearly list grade A. A lot of other sites will list grade A, and most of them will come with warranties as well. So that's a really good option. So with Macs, I would shoot for anything in the last 3 years would be what I would do. I'm not sure exactly what the specs from 3 years ago would be, but 3 to 4 years, yeah, you should be fine.
So Jennifer has a 14-year-old interested in coding. Where would you start at that age?
For a 14-year-old, again, you could start with Scratch just to kind of get some of the basics filled in. Again, 14-year-olds tend at that time to have a very nice level of mathematics, like their foundations are there. They understand algebraic thinking to a degree. For 14, I like sites like CodaKid is excellent for 14 because you're able to build real games. You're able to use professional tools and languages. Kids really feel like software developers when they use our stuff. So I do think that is a sweet spot for us. Other sites, if you wanted to go with some free materials, you could look at KhanAcademy.org. They have some tutorials online that are quite good. Another free option, if you go to the CodaKid website, go to our blog, and we have a few really fun free activities that you could do to try it out. That will show you how, for example, if you're into Minecraft modding, we have a free lesson that will show you how to basically get Forge set up on your computer, how to get Java set up, and basically how to build your first mod. And that's all free and available on our website.
Wonderful. And then do you have any other resources you would recommend for high school students?
Well, let's see. The resources like there are some, RoboLink I had given earlier is excellent for high school. I think that would be more than appropriate. If you'd like to try, if you have a very bright high schooler who can work independently, I do really like the website Udemy. It's, here, I'll spell it here. It's, and Udemy is, they sell individual courses that are, again, video tutorials. They are designed for ages 18 and up. The content is 100% safe and family friendly, but the rigor level is typically like it's for adults. But I've found that some of their HTML, CSS courses are perfect for high school. I really like some of their Python courses. They're inexpensive. They're asynchronous. You won't get any support from them, but it's an excellent resource that I think would be great for high school.
Awesome. Thank you so much. For everybody who's attended here today, I want you to know we will send a link with this recording in the next day or two. And I'll also be sure to send all the links that David mentioned during this webinar so that you have those resources at your fingertips. I hope you will all join me in thanking today's host, David Dodge. David's program, CodaKid, is an award-winning online coding course, and it really is perfect for homeschoolers. You can get it at the co-op and save 80%, but we do encourage you to check out all these different resources out there. It's a really wonderful skill set to share with your children. So thank you all so much for joining us and sharing your time with us. I hope you all have a great day.
Thank you.